So let us learn about the load dependent cylinder liner cooling water system in two-stroke marine diesel engine. See what is happening in this. Why do we need first the cooling of the cylinder liner? Because inside the cylinder liner combustion is taking place. Due to this, heat is getting generated. So this heat will keep on transferring to the cylinder liner if we don't have cooling water system. So the liner temperature, the cylinder head temperature, your exhaust valve temperature will keep rising, 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 because you're not taking away the heat from these surfaces where the heat is being transferred from the combustible gas, the combustion. So for that reason, cooling water is provided. For that reason, cooling water system is provided. In conventional system, the cooling water was sent through the jacket which is surrounding the liner, and after coming out from the jacket it was entering into cylinder head and then to exhaust valve, cool down and return back to the expansion tank through the orifice. In conventional system, the flow of water was maintained the same. So it means if the load on the engine changes, means, see, the marine engine is designed for running at different load, at low load, high load, normal load. So when the load increases, the transfer of heat to the liner, cylinder head and exhaust valve increases. So there you need a system, the cooling water system, which maintains the cylinder wall, that liner wall and exhaust valve in a designed operating optimal range. So suppose the manual prescribe says that okay, at high load you should maintain the inlet temperature 70 degree and outlet temperature 85 degree. So this full flow of water is doing that, is solving that purpose. Now when the load is low, the heat is not much inside. So liner temperature with that flow of water will definitely come down, though you have set the temperature to a higher level, but still it will come down. So this coming down of the temperature of the liner wall is dangerous, because once the temperature inside the cylinder liner or inside the combustion space drops below the dew point of the vapor, dew point of the vapor, you know that air is having the water vapor also. So if the temperature falls below or to this level, the water droplets will form. And in fuel there is sulfur. So when it burns, it produces the oxides of sulfur. So that oxides of sulfurs are easily dissolved into the condensed water droplet, and form the acid. And you know that the acid is highly corrosive for the metal. So it will start corroding the metal. So wherever it is getting deposited, like on the liner surface, if it is getting deposited, it will start corroding it, eating away the metal. If it is on the cylinder head, it will start the component of the cylinder head in that location the corrosion will initiate and it will eat away the metal. Same way for the exhaust valve. So whichever passes it is passing through or wherever it is forming the sulfurous and sulfuric acid. So running the engine at low load is a challenge. How to maintain the temperature inside the cylinder or cylinder wall temperature to such a level where it does not come down below the dew point, so that water droplet will not form, gas and water vapor in the air will pass out in the exhaust system. So for that reason, an additional system has been introduced that is called LDCL, load dependent cylinder liner cooling water system. An additional pump is installed in addition to your jacket cooling water pump. And this pump with the flow control valve solving the purpose of keeping the jacket cooling water inlet temperature to the liner at higher degree, so that the liner temperature, wall temperature does not fall below the dew point. So this way you can avoid the condensation and the cold corrosion. This is called cold corrosion because the engine is running on low load, it is generating less heat, so liner temperature has a tendency to fall down if we run with the conventional system of cooling water system. But with this system, in addition, you are keeping inlet temperature itself at higher degree, so that wall temperature does not fall below the dew point. So one thing, the LDCL system will prevent the cold corrosion. Second thing, when the liner temperature is optimal, optimum means to a design level, like okay, from this much to this much, higher at low load. So your thermal efficiency will be higher. Why? You know that heat transfer is depending on the temperature difference between the two bodies. So if your liner temperature itself is at higher temperature and the cooling water temperature also is at higher level, so difference will be less, and that is why less heat will be transferred to the cooling water, and by this means liner temperature we can maintain at higher degree. Third thing, efficient combustion. Like I have written in the point over here, efficient combustion. How do how how the higher liner temperature at low load aid to this efficient combustion? For the combustion, what you need, because it is a compression ignition engine. So when you compress the air, the temperature rises and the fuel is injected at that temperature, the fuel ignites. But when your liner temperature itself is low, so when you are compressing the air, it will not, it will reach to the ignition temperature but not evenly distributed. Maybe at some location the temperature will be less, at some location it will be higher. So the places, the location where the temperature will be higher, the fuel will burn first. And maybe when your piston is coming in the downward stroke, the combustion of the fuel injected becomes little late, so you will get the lesser high peak pressure. So with the lesser peak pressure, you will be able to extract lesser power from the combustion of fuel. That is what it means, efficient combustion. Reduce thermal stress. When the temperature of the cylinder liner itself is at higher level, the thermal stress will also be less because the heat transfer now is less. If the temperature difference is too much, so it will become cooler. Cooler means it will shrink in, the dimension will reduce. Hotter means it will expand. So by running it on higher cylinder wall temperature, your thermal stress will also reduce. Third thing, no condensation inside the cylinder liner wall. So your film lubrication, cylinder lubrication film will be maintained and it will reduce the wear. If not, if suppose the water would have formed, condensation would have occurred on the cylinder wall. So your lube oil will wash away. The cylinder lube oil will wash away. In that area, there will not be an oil film between the piston ring and the liner. So mechanical rubbing will start. And that will increase the wear rate. So by keeping the higher temperature, you are reducing the, you are controlling the or minimizing the wear also. So these are the points which has been written. You can go through like prevent cold corrosion. At low loads, the cylinder liner temperature can drop, leading to condensation of sulfuric acid and sulfurous acid and accelerated corrosion, increasing the cooling water temperature, which I have already mentioned. Improve the fuel efficiency, even temperature inside the cylinder, so that when the fuel is injected in atomized condition, the burning will be smooth. Reduce thermal stress. How it works? The system typically uses sensors. LDCL is having the sensors which senses the load on the engine, the temperature sensor, to monitor engine load. And if it senses that the engine is running on low load, the flow of the cooling water through the cylinder liner, it will reduce. So in one cycle, the temperature will increase. So for that, you have the temperature regulating valve controls, which controls the inlet cooling water temperature to the engine depending on the engine load. At low load, the temperature is increased to avoid cold corrosion. Bypass control. Some system uses a bypass valve to control the amount of cooling water that flows through the cylinder liner jacket. At low loads, some of the cooling water is bypassed, reducing the cooling effect. So key components of that LDCL system is the pump, sensors, control system, and control the flow of cooling water. So you can go through this. This is self-explanatory. And this is the diagram which you can understand. This one is your jacket cooling water system. From there, from the pump, jacket cooling water pump, the water is pumped. It goes to this line where it has the three-way valve. it also flows in this line. It has a non-return valve over here. So this water will not go this side. Rather, the water can come in this side because this is a non-return valve. So this water will come here. It will go to the LDCL circulating pump, and then it will pass through and enter into cylinder liner jacket. And from here it will come out and it will go to the three-way valve, and from there it will divert to the cylinder head and exhaust valve, and then after cooling it will go back to the jacket cooler cooling water system. So it will go to the jacket cooling water system. Now you can see that what happens at low load. Your purpose is to increase the inlet temperature, means this one. So what is happening? This is, if this is a variable pump, variable discharge pump. So this will pump the lesser water through it. So lesser water means less cooling. So even if the water is coming at 75 degree, it will do the less cooling, and the cylinder liner wall temperature will be higher. And after cooling this, it will come out at a higher temperature, and this will go over here in three-way valve. From the other side, your jacket water is also coming. So depending on which way this three-way valve is open, is it partially open this way and this way, or this way only it is fully opened? If it is open fully in this way, so all the water which is coming out of the liner will go here and directly enter at higher temperature to your cylinder head and exhaust valve. So that way it will keep the temperature of the cylinder head and exhaust valve also at a higher level beyond the dew point. So this is the way it can maintain the cylinder water temperature, cylinder wall temperature. For that, the system will be having a temperature sensor or load sensor, which will sense the load, at what load the engine is running, and what temperature at that load should be maintained will be processed through a control unit. That control unit will accordingly process that signal to send the water in the cylinder liner. If it is a flow control type, so the flow will be less. When flow is less, the cooling will be less. The cooling is less, the wall temperature will be higher. So hopefully you understood the system. The main purpose is to prevent the cold corrosion, improve the engine efficiency at low load, reduce the wear, because wear will happen because of the droplet forming and lube oil film breaking. If anything more you want to know in detail, or wherever you have the confusion in understanding, you can write in the comment box. I will elaborate on that point. Thank you.